Hey class, this is Mrs. Anderson. In this video, we're going to learn to graph the sine function in the form y equals a sine of bx. So before we do that, we're going to review the unit circle a little bit. And I'm not going to go into too much detail here in the video on the unit circle. It's kind of a pretty cool thing, and you could really talk a lot about the unit circle and how it works. But we're going to just address some of the few things on the unit circle. So the unit circle is a circle that has a radius 1. So it has an equation of x squared plus y squared equals 1. So a circle with a radius of 1. And if you remember, when you go around the circle, the positive x-axis starts at 0 degrees or 0 radians. And then here at the positive y, that's 90 degrees, or we'd say pi over 2 radians. And then over here we have 180 degrees, or pi radians, 270 degrees, and that would be 3 pi over 2 radians. And then you have also 360 degrees all the way around the circle, or 2 pi. Now, what's really interesting about the unit circle, we've kind of talked about the quadrants before and how we have the acronym all students take calculus. That tells us the trig functions and their values in those different angles, like if they're positive or negative. Well, these points along the unit circle, like this point right here, since it has a radius of 1, that point is 1, 0. The point at 90 degrees, the radius of 1 will be the point 0, 1. The point at 180 degrees on the unit circle is the point negative 1, 0. So I'm talking xy coordinates here. And the point at 270 degrees is the coordinate 0, negative 1. Now those are the 4 coordinates I'm going to focus on. And those are actually trig values. The ordered pairs are cosine of theta and then sine of theta. So cosine corresponds with the x coordinate of the unit circle, and sine corresponds with the y coordinate. So if I just focus on those 4 coordinates, I could say like the cosine of 0, I meant to put cosine of 0 radians or 0 degrees is 1, because the x value there is 1. Or I could say the cosine of pi over 2, or the cosine of 90 degrees is 0, because the y coordinate there is cosine. And then I could also say like the sine of pi, or the sine of 180 degrees, would be 0 as well, because the sine corresponds with the y values along the unit circle. And these actually, you could continue to fill this unit circle out. The first one, this first line right here, is at 30 degrees. And so the ordered pair for that point right here, xy ordered pair, is if you drop the thing down and you look at the unit, or like the special right triangle, it would give you the 30, 60, 90, the values 1, square root of 3, 2. This point actually corresponds to the cosine and sine of 30 degrees. So cosine would be the square root of 3 over 2. And sine of 30 would be 1/2. So that's the xy coordinate that corresponds to that point. The next line is 45 degrees. So cosine is square root of 2 over 2 of 45. And sine is square root of 2 over 2 of 45 degrees. And the last dot right here is 60 degrees. And then that one, cosine of 60 is 1/2. And cosine, or sine of 60, is square root of 3 over 2. And like I said, you can go in quite in depth in the unit circle, and it continues to go around. The next one, like this one here, is 150 degrees, and so it has a reference angle of 30. So it has the same values as the 30 degrees on the other side, except for that since you are in the second quadrant, only the sine is positive, so the cosine, or the x coordinate, is negative. So it's a negative square root of 3 over 2 and 1/2. I'm going to go in more detail about that in class, I think, with the unit circle. So the ones we're going to focus on and use to graph are these 4 quadrants around the circle. And sine and cosine kind of worked like this. So I'm going to pull in this little YouTube clip that's going to show you a visual of kind of how this works. So graphing sine.
Theta, and remembering that sine is all to do with the y coordinate of the point on the unit circle. And so we see how sine changes as theta changes. And so using this idea or this definition of sine, we're now going to look at actually creating the sine curve. So as the angle gets larger, sine gets larger, then smaller again, back down to 0, down negative to -1, and back up to 0. And in one rotation of the unit circle, we see this relationship occurring between the value of theta and the value of sine theta. And so what we note now is that if I were to lap the circle again and go from an angle of 2 pi around to 4 pi, I would see exactly the same thing occurring. Similarly, 4 pi to 6 pi, 6 pi to 8 pi, etc. We're going to see exact same repetition of this.
So as we go around the circle, the sine function starts at 0 and then goes to 1 and then back to 0 and then back to -1 and then back to 0. And it makes that kind of that loop here that we're going to see. So like we said, it starts at 0, then it goes up to, it has 4 sections. It goes up to 1, then it goes back down to 0, it goes back to -1, and then it goes back up to 0. And like you saw in the video, that's one rotation around the circle. Now sine will continue on forever like that. So if I look at, I pulled it up here on Desmos, this is one that you can see outlined in the blue and purple square here. That is one period of sine. So it starts at 0 and it goes from 0 to 1 and goes up to 1 and down to -1. But if I zoom out, you can see that the sine wave goes on forever. So the more rotations around the circle you make, the sine function will continue to go on forever. Now we have some key pieces of the sine function that you maybe saw here in your notes. This would just be the y equals sine of x. We're going to look at the a sine of bx is what we're going to graph today. And we'll notice that when I look back on my graph here, if I change a changes the height of the sine function, which we're going to call that the amplitude, and then b changes the period. So as b gets larger, the period moves, stretches out. If you shrink b, it shrinks down. So remember, the period is outlined with that square, the blue and purple square. So we can move the period and stretch it or shrink it, and then the a changes the height or the amplitude. So those are some key features of the sine function that we're going to graph. And so that's our goal today. So let's look at a couple more key features of sine. This is actually for sine and cosine. So the domain is all real numbers for both. So that's all the x values. The range fluctuates between -1 and 1 unless the amplitude is changed. So it's periodic, which means it's a repeating pattern that continues infinitely. The cycle, it's the shortest repeating pattern. So one cycle is what you saw I graphed from 0 to 0. So it starts and stops in the same place and you get that full curve. That's one complete rotation around the unit circle, 360 degrees. That's one cycle. So that's what we're gonna graph, just one cycle, and then it's gonna go on forever. So the period is the horizontal length of each cycle. So that's going to be what we're going to put on the x-axis. Typically the period length is 2 pi. We're going to look at, this is the parent function here. Maximum value, or m, that's going to be our amplitude, essentially. Our minimum value will be the negative of that amplitude then. And how we find our amplitude, it's the measure, or it's the vertical height. Here's an equation. We're going to need that in the third section, more importantly, when we're trying to look at the graph and try to find the amplitude from the picture. But if you take the average of the heights, or if you take the max height minus the min height and take the half of that, it equals 1 in the parent function. So that's how you can find the amplitude too if you're unsure. So here are some key features of these graphs. So this is this equation up here, sine of y equals a sine of bx, or y equals a cosine of bx. So a represents the amplitude or the vertical height, and then we're going to find the period. Remember, that was the horizontal length of the cycle, and we're going to find that by taking 2 pi over b. So the maximum values, we're going to say that that's our amplitude, and our minimum value will be our negative amplitude. Our x-intercepts, we're going to have in each cycle, there's going to be a couple x-intercepts, and we're going to find those by breaking our period into force. So that's whenever our x is 0, and then we have a coordinate. In this case, it would be sine of x. So you'll see what I mean here. Okay, so we're going to look at the general equation as y equals a sine of bx. So a is the amplitude. So out front here, we have nothing, so that means our implied coefficient for sine is 1, which means our sine graph will fluctuate between 1 and -1. Our period we find by taking 2 pi over b. And this 1/2 right here is our b because it's in front of our x. So our period will be 2 pi over 1/2. Now, to take 2 pi divided by 1/2 is the same thing as 2 pi times 2 over 1. So really, our period is going to be 4 pi. And we're going to take and create a table of values. So a period is 4 sections. We're going to divide this graph into 4 sections, which means we're going to start at 0, and then we have 4 sections. So really 5 spaces, 1, 2, 3, 4, 5. And I know that my period length is 4 pi, so my ending length is 4 pi, and then I need to cut it into even force. So even force, I could take 4 pi and multiply it by 1/4 or divide it by 4. So 4 pi divided by 4 is going to be pi. So that's going to be my very first interval, and that's going to give me what I'm counting by. So that means I'm counting by pi's. 1 pi. The next one will be 2 pi, 3 pi, 4 pi. So pi, 2 pi, 3 pi, 4 pi. So figure out your period and then cut it into force, and that figures out your first spot, and then that's where you're counting by. Then to get the y coordinates, I'm going to look at the unit circle. And I'm going to look at those 4 main points I outlined right here. So this point was 1, 0. Here is 0, 1. Here's -1, 0. And then down here we have 0, -1. Which means that when sine starts, you start your theta here at this angle, your initial side. Our points are cosine, sine. So sine corresponds with the y coordinates of this unit circle. And so I start at, when I'm at 0, my sine is at 0. Okay, when I move up to my next point, my sine is at 1. When I move down to my next point, my sine is back at 0. As theta gets larger, my sine goes down to -1, and then my sine rotates back. As my theta rotates back, sine value goes back to 0. So on my graph, and then I have the points on my graph 0, 0, pi to 1, 2 pi, 0, 3 pi, -1, 4 pi, 0. And then that's going to continue infinitely in the same cycle. So I've graphed one cycle or one period of this sine function using my unit circle. So let's do another example. Hopefully, if you didn't quite catch on. So this one does have, if you wanted a domain, it's all real numbers. And then range, you can see that it goes between, the y values go between -1 and 1. So my range is between -1 and 1. All right, so I need to identify some key features. So first I want to look at the amplitude, which is the A value out front here. So amplitude is 2. And then my period, I'm going to find by taking 2 pi over my b value. So my v value is with my x. And then remember that x divided by 4 is the same thing as 1/4 times x. So b is 1/4. So I'm going to 2 pi divided by 1/4. So again, 2 pi multiplied by the reciprocal, 2 pi times 4 over 1 is going to be 8 pi. So my period will be 8 pi, which means when I divide this into fours, I'm going to end with 8 pi. There's a couple ways to do this. First, when I divided it by 4, you could cut it in half and say 8 pi cut in half is 4 pi. Cut that in half and you get 2 pi. Then you know that you're counting by 2 pi. So 2 pi, 4 pi, 6 pi. The other way to do it is when you look at your table of values, you always start at 0. And then you know you're going to end at 8 pi. So you take 8 pi and you take that times 1/4 or divided by 4. And that gives you 2 pi. And that's your first one. Then 2 pi, 4 pi, 6 pi, 8 pi. That's what you're counting by. So that gives you your period. This is just one cycle of the sine curve or the sine. Then I use my unit circle. And eventually you'll have these memorized the more you practice it. But 1, 0, 0, 1, negative 1, 0, 0, negative 1. And sine's going to start at 0, then go to 1, 0, down to negative 1, back to 1. So it's going to make one full cycle all the way around, starting at 0. So it's going to go 0, 1, 0, negative 1, 0. So sine and cosine, for that matter, will both start and stop in the same places. So sine starts at 0, 0. Now I did have an amplitude of 2. So that's like my AY column, which means that if you multiply everything in here by 2 and just graph the first and last column, I'm not going to fluctuate between 1 anymore. I'm going to go between 2 and negative 2. So sine starts at 0, 0. Then I have 2 pi and positive 2, 4 pi 0, 6 pi negative 2, and 8 pi 0. So here's my one cycle of my sine curve. Then domain would be all real numbers. And range this time would be the y values are fluctuating between 2 and negative 2. So my range would be negative 2 to 2. So let's just practice finding the amplitude and the period, because once you find that, you're going to use the same pattern for sine, which was that 0, 1, 0, negative 1, 0. So that's going to be around the unit circle. So finding the period of the numbers that go in here is a little trickier, and then finding the amplitude, so how high you're going. So let's just practice that. So the amplitude is what's out front. So this has just a 1 sign. So amplitude is 1. Period is 2 pi over b, where b in this case is pi. So 2 pi over pi will reduce to just 2. So a period of 2. So that means that this is 2. Then 2 divided by 4, 2 times 1/4 would be a half. So that means in this one you're counting by halves. So it would be 1 half, 2 halves, 3 halves, 4 halves, which you see 4 halves reduces to 2, 3 halves, this would reduce to 1. So cutting it into fourths, and then that's what you're counting by to find your period. The standard 2 pi period, that one follows the unit circle where you start at 0, then it's pi over 2 for 90 degrees, and then pi for 180, and then 3 pi over 2, and then 2 pi. So 2 pi is the parent function standard period size. So this one has an amplitude of 3, that's my number out front, and this one has a b of 1, so 2 pi over b would just be 2 pi over 1, so it has a period of 2 pi. which like I said is the standard unit circle. It corresponds to the 0, degrees, 90, 180, 270, 360, 2 pi, 1 full circle. Let's practice writing an equation of this form, y equals sine of bx. So my amplitude is my a value, and my period here is given to me as pi. But remember, the period was found by taking 2 pi divided by b. So the period doesn't go in the equation, but the b does. So if I set it equal to this, I can solve for b. I think it's easiest to solve this by cross multiplying. So I get b times pi equals 2 pi times 1, so 2 pi. Divide both sides by pi, and I would get b equals 2. So then the equation for this first example would be y equals 2 sine of 2x. So amplitude of 2 and period of, or b equals 2. Amplitude of 1/2 would give me 1/2 sine. And then to find the b, take the 3 pi and set it equal to 2 pi over b. And then solve for b. So cross multiply, we get 3 pi times b equals 2 pi times 1 is just 2 pi. So when you cross multiply, the products are equal across. Then solve for b, I'd have to divide both sides by 3 pi. So this would cancel, this would cancel. I'd get b equals, the pi's reduce 2/3. So it'd be 1/2 sine 2/3 x. Because a goes in front and b goes in front of the x. So an amplitude of 1 would start us out as just a sine. And then if my period is pi over 2, so if that was equal to 2 pi over b, what would my b equal? So cross multiplying here would give me pi times b. 2 times 2 pi would equal 4 pi. Divide both sides by pi to get b isolated, and I would get b equals 4. So to finish off my equation, it would be 1 sine of 4x. Last one here would be, starting out would be sine of 1/4, y equals 1/4 sine. And then to solve for the b, again, we do 2 pi equals 2 pi over b. This one I can probably notice right away that b will be 1. But you can cross multiply. 2 pi times b equals 2 pi. So divide both sides by 2 pi. And if everything crosses or simplifies, it equals 1. So 2 pi divided by itself is 1. Which means it's just sine of x. All right. So to graph the sine, and we're going to talk about cosine in the next video, find the amplitude, find the period using the 2 pi over b. Maximum values are your a, minimum values are your negative a's. Find your x-intercepts by cutting the graph into fourths and then counting by that. Using your unit circle pattern to make a full loop around the circle. I should have started here and then all the way around 360 degrees to make one cycle of the graph. All right, it's kind of tricky and it's a little hard to explain via YouTube. So check out some other the videos that I've posted or other videos, or see me, of course, if you have more questions. Hope it was helpful.